Hi everyone, my name is Wes, and this is a project for IST 753 in the iSchool at Syracuse University. And I just want to show you, we built an enterprise, essentially an enterprise network. I just want to show you a little bit about it. So starting from the top, we have our NAT router, which is our connection to the internet. And then from there, we go to our core, which splits into two redundant routers, which are linked via HSRP. So if one of them goes down, the standby will automatically fail over and become the primary for each VLAN. And on this particular network, we happen to have 5 VLANs. As you can see, we have 2 for our residence halls, two for the colleges. And then we have a data center. The data center happens to have a web server, a DNS server, and a DHCP server. And the DHCP server has a scope defined for each VLAN. These are actually layer 3 switches, so they do both routing and inter-VLAN routing. The primary layer 3 switch for each VLAN is also the default gateway for the particular VLAN. Now I kind of just want to show you our physical implementation of this network. So starting from the top again, we have our NAT router that goes into our switch, which splits down into our core layer 3 switches, which then goes into each of the specific VLANs. But we have the 4 VLANs represented in one switch. And the way we're doing that is we have ports dedicated to each VLAN. So these 2 ports are VLAN 10, VLAN 20, VLAN 30, and VLAN 40. And again, C1 and C2 are redundant copies, they're duplicates of each other. But C1 is the primary, with HSRP is the primary for VLANs 10 and 20, whereas C2 is the primary for VLANs 30 and 40. So when we're running in the full, our 100% configuration, the traffic from VLANs 10 and 20 go to C1, and the traffic from VLANs 30 and 40 go to C2. Whereas one of them fails, all the traffic will either go to C1 or C2, depending on which switch has failed. Now I kind of want to go through and give you a demonstration of our network to show that everything is indeed working the way it should be. So I will start. This computer happens to be on VLAN 20, which is one of our residence halls. So the IP address of this particular computer is 172.16. We have a 172.16 IP scheme throughout the network. .0.11 with a /22 mask, 252. So the gateway for this particular machine happens to be 172.16.0.3. So the way HSRP works is you configure a VLAN, the VLAN gateway on each switch, and then you configure a common gateway for the VLAN between the 2 switches. So C1 happens to have 172.16.0.1, C2 happens to have .0.2, and the gateway is 0.3. And as you can see, I can ping .3. So now I'm going to ping the default gateway to get to the internet, which is 172.16.15.3, if I enter the correct command. That is good. And now I would like to test the NAT to make sure everything works there. So I will ping google.com, good old Google. And as you can see, that comes back correctly. So now that the network is up and running, actually to show you one more demonstration is I'll ping a another computer on a different VLAN. The other computer is 172.16.4.10. It's on VLAN 30, which is in the iSchool. So that comes back right. The last thing to check is HSRP. So 172.16.0.2 is the IP address of the VLAN gateway on C2. So that pings correctly. So everything is fine there, and I'm going to pull the access to that switch. So as far as my workstation is concerned, the default gateway is down. So it's going to take a couple seconds for the HSRP to kick in, where C2 will become the primary for VLANs 10 and 20. So we'll take a second, and it comes back up. That took about 20 or 25 seconds, which is good to see that you can have a robust network and not have to worry about your core going down because you have redundancy built in. Part of the reason that it was so quick was we have rapid spanning tree enabled on the network on each of the switches, which cuts the time in about half. During our initial configuration without the rapid spanning tree, we're seeing about 50 to 55 second failover rates, which frankly in a network, in an enterprise setting, would be unacceptable, whereas a 20 or 25 second downtime is more acceptable. So now I'll plug this back in and show that C1 will become the primary again for the network. So I'm going to stop this ping and ping .3, which is this is the gateway for this VLAN as far as this PC is concerned. So we'll wait a moment for that to come back online, which will hopefully be soon. Let's see, some of the other things that you should know are okay, so we're back online. As you know, it's really not that long for the failover to happen, which is good. You wouldn't want a long failover time. But back to what I was saying before, the NAT, we're using a static IP address assigned to us by the university. So our NAT router is forwarding everything. There's a static route to the gateway for the particular network that this NAT router is connected to. Okay, so I've guided you through the network. I have shown you HSRP. I've shown you that everybody can talk to each other, which is always good. And if you'd like to see any further, you have any further questions, we have documentation available that you can read through and see our configuration. But that's it for now. Have a good day.